Hey everybody, today we are going to be generalizing the integration by parts formula. Wow, it's going to be crazy. So I hope you're comfortable with sums and products like this. I hope you're comfortable with this notation. And speaking of this, this is the product rule. This is what we're going to be basing this off of. I've made, I think, a couple of videos on deriving this formula, so I hope you already know how to do that. I'll leave a link in the description to those videos. So today we're going to be kind of jumping off of that using this formula because the integration by parts comes from the product rule. So I think I have made a short on that, so you can watch that real quick. So I'm going to assume that you watched that. I have it in the description, but let me just kind of show you integration by parts, but kind of the third, I'm sorry, with like 3 different inputs instead of just 2. So I'm going to be using a green marker today, just because why not? Let's say we had to take the derivative of u, v, and w, right? So I know this notation isn't totally proper. We technically have to have like a dx down here, but you can kind of think, I'll show you the whole thing later. So we know this is going to be u, v, dw, right? dw is just kind of the derivative of w plus u w dv plus v w du, right? So technically, you can kind of think I multiplied all of these by dx just to kind of get rid of the dx. This is kind of an improper way of writing it, but it works, okay? So the derivative of this whole thing is equal to this, okay? So if we want to find what one of these is equal to, well, what we can do is we can choose whether we want to solve for this guy, or this guy, right? Of course, first we have to integrate all of them, right? Just because this is the integration by parts. So the integral and the d will cancel. So we're left with just u v w. But let's say I want to solve for this guy. So I'm gonna swap the size of the inequality here. So I'm gonna say that we have the integral of u v dw. So this guy is on this side now, so it's gonna be u v w because these guys cancel. And then I'm going to subtract these two, minus the integral of u w dv, minus the integral of v w du. Okay, so yeah, I just chose this, solved for that, and we get this expression. I could have also solved for this guy, or this guy. I chose to solve for this. So whenever we generalize this, we're not only going to be generalizing kind of how many the number of terms that we're multiplying, we're also going to be taking into account that we can choose any one of these. So it doesn't have to be one particular term that we're solving for. It could be any term. It could be this, this, or this. But of course, when we have n inputs, we're going to have a bunch of different outputs. And I mean precisely n different kind of things we're adding. So we have n different choices of what we want to do, basically. So let's use this in mind, or let's keep this in mind and use it to kind of think about how we're going to work with this. So notice how whenever we take the derivative of this guy, right, this is the same thing here, we have these different outputs, right? And these plus signs are being replaced by this sigma here. So what we need to do is, kind of got rid of this, what we need to do is pull out a particular term from here and then solve for that. Because here, this is all of the terms at once just being added together with this guy. So we need to pull out one of them and solve for it. So I wrote it out. Basically, we have the derivative of this guy, right? This is going to be equal to, I'm going to say all of this except for the first term. I'm just going to start with the first term, and then we're going to add in the first term. So what do I mean by that? So I'm going to say we have something here plus, we're going to sum up everything from I equals 2 to k of f sub I prime over f sub I, so f sub I prime over f sub I, times the product, again from I equals 2 to k, of f sub I, okay? So notice how this is exactly the same as this, except we don't include the first term. So we have to add in the first term. So the first term is just going to be, it's going to be f, we can say f sub 1 prime times the product from I equals 2 to k of f sub I. Okay, so it's going to be this plus that, because this is just, you know, first prime times all the rest, and then second prime times all the rest, and so on and so forth, right? It's just how the product rule works. I could have also made it, instead of us picking the first term, I could have said, okay, well, what if we pick the second term? So it's going to be f sub 2 prime times the product of our fi's plus the sum. Oops, that's weird. That's weird how it did that. So then we're going to be adding the sum of our fi primes over f sub I times the product of f sub I. Okay, but our indices are going to be weird, because it's going to be like I equals 1 to k, but not 2. Same for all of these, and it's just going to be weird. So the way we do it is we're not going to be using this particular way of writing it. Right, we're going to kind of erase this, because there's another way we can write this out. And it's used more commonly in more kind of advanced fields, and this is kind of fitting here. And it's very convenient, because basically we write it like an inequality. So we say, okay, well, I, our index, is going to be greater than or equal to 1, but less than or equal to k. So I goes from 1 to k. Alright, and actually in this case it's going to be 2, because we started at 2. And so for this one we can just write, this goes from 1 to k. So I goes from 1 to k. Okay? And then same thing for all these. So this is going to be 2, so 2i k, and then 2i k. Alright? So I goes from 2 to k. Right? So, well, I don't know why I wrote this one down so low. But this still doesn't help us, because it's going to be like 1 to k, but then not 2. So the way we write this is it's going to be going from 1 to k, so I goes from 1 to k, but then we say that I is not equal to 2. So we can write it like two different things down here. And that's okay. That's completely fine for us to write kind of two different lines of stuff there. And same thing for all these. So we can say so I goes from 1 to k, but then I is not equal to 2. So then I goes from 1 to k, but then I is not equal to 2. And for this case, up here, it would just be I goes from 1 to k, but then I is not equal to 1. Now it's kind of weird to write, but it kind of helps whenever we develop the general case. Because in general, we can say this is going to be f sub n prime times the product from, again, I goes from 1 to k, but not including n, where n is just something here. So I'm going to write down that n is between 1 and k. It's any one of them, right? And so then I can write down the rest of the formula just that way. Okay, so, and then remember that this is still the derivative of the product of our f sub i's, and again, this is going to be I from 1 to k. And here we are including, I'm not going to include the second line because we're actually multiplying all of the products. Here, it's just, I pulled out one of these terms, and that's why we have this extra condition on the bottom, because I pulled one of the terms out. So again, what's the point of me pulling out one of the terms? Well, that's because I wanted to integrate everybody. So I integrated this, integrated that, and integrated this. And notice how whenever we did that first example at the beginning, I had like a bunch of integrals here. Here, this one integral is kind of integrating like a bunch of different things. Exactly k of them. Actually, k minus one of them, because one of them is here. So this is the one I pulled out, and this is the one I'm solving for. So we can say that the integral of f sub n prime, where again, I didn't mention this, but these are all functions of x, right? So f sub n prime times the product from 1 to k, where I is not equal to n, of dx, I didn't include the f sub I here. There we go. Of f sub I dx. So this, the integral of this is what I'm trying to find. This is equal to, so the derivative and the integral will cancel. And it's precisely equal to the product here from 1 to k of f sub I minus, because I kind of just swapped the sides of the equal sign, so it's going to be minus this. And you can put parentheses around some of these things if you want. But yeah, this is the whole thing. So yeah, it's very like huge. But this is the generalized integration by parts formula, this whole last row. And basically it's saying that if you take the integral of a product of functions where one of them is the derivative of some function, this is going to be equal to taking the product of all the functions and then subtracting off this expression, which is exactly our product rule, except for one of the terms. And one of those terms is this one that you actually integrate. So basically what this means is you have to know the integrals of every single, or actually, yeah, you need to know the derivatives and actual functions of every single other function that you're working with. And then you should be able to integrate all of them basically together, and then subtract that off from all the functions multiplied together, and that way you can get that integral. Is this practical? Not at all. This would take an extremely long time to be able to figure out, especially if you have a large number of functions. But this is kind of a cool little thing for generalizing this. You know, it's taking this guy and making it 10 times worse because you have to integrate all of them. But yeah, so it's just something I wanted to work with today. So I hope you guys found this interesting. If you did, then I hope you will find out some of my other videos interesting. So thanks for watching, and I will see you in the next video. Bye, guys.